Hello, hello students. As per the so many students request, they are asking me to discuss about integral calculus. So today's we are going to discuss some important concept of integral calculus. Now, so many students they are requested in integral calculus how to reduce the given integrand into reduction formulas. That's right. Today we are going to learn reduction formulas in integral calculus topic. So integral calculus. And in that integral calculus, there is a simple important topic that is called as a reduction formulas. Reduction formulas. Now, why to study this reduction formulas and where it is going to useful? Actually, the aim of this chapter is to take the higher level by introducing them into some advanced techniques of the mathematics, and to reduce the complicated integrals into a soluble form by using mathematical or algebraic expression. While reducing the given integrand, if integrand contains functions which are infinitely integrable or differentiable function, even such integrands also you can easily solve by using this reduction formulas method. The many of the functions occurs whose integrals are not immediately reducible to one or two standard form, and in such cases we have to use some algebraic formulas where we can use a previous step or second step or third step, previous back steps you have to use to get a particular formulas, and by using that algebraic concepts we get a fundamental a formula, and that formula we can say is easily soluble for the given complicated integrals. Now we'll go for one simple examples and how to reduce. Now suppose we have integral 0 to pi by 2 or any integral sine raised to n x dx, sine raised to n x dx. Now initially we'll assume that this integral we treat it as I n, and without limits you take the integral first. Integral sine raised to nx dx. This is a suppose this is our given integrand sine raised to nx dx. Now this integrand sine raised to nx, it's a infinitely differentiable as well as infinitely integrable function. So such cases we split up this integrand, this is called as integrand term, this integrand term into two terms such way that out of that one is differentiable and one is integrable functions. Then here we are going to use UV rule. UV rule. And what is UV rule? First as it is integration of second minus big integral derivative of first and integration of second, and such a way that we can solve questions. Now for this present example, integral in can be written as integral sine raised to n minus 1 x into sine x dx. Means here I splitted this raised to n into two terms, one is n minus 1 and one is sine 1x dx. Now for this integrand we are going to use UV rule. Now out of these two can use one function is u and second function is v. You can choose any u and v, but while choosing u and v, you must be clarify that the function must be differentiable as well as integrable, such way that you can select the terms. Now this we are going to now learn how to make it. Now in equal to, first take first term as it is. Now I'll take here sine raised to n minus 1 x as it is. Integration of second means sin x dx minus big integral derivative of first term sin raised to n minus 1 x. This is first term. Now again integration of second term. Integration of second term. This is the second integral, and this now dx is for the bigger integral. Now we got this is expression. Now in this now integrate the terms which are integrand. Sin raised to n minus 1 x keep as it is. Integration of sin x. Integration of sin x is, now we have integration of sin x is minus cos x minus cos x. Then now again minus sin. Now inside the integration sign, this is integral derivative of sin raised to n minus 1. Therefore n minus 1 into sin raised to n minus 2. Already here is 1 is there. After differentiating it, it becomes n minus 2 x. And this is not only sin or single x, it's a sine function. Sin ka derivative again we get cos x. Sin ka derivative cos x. This is the derivative of first term. Now again we have to use the concept for integration of this one. This integration that we can I'll write here minus cos x minus cos x and whole, this is bigger integration dx, bigger integral symbol for dx, and this can be written as minus sin raised to n minus 1 x into cos x into cos x. Now again here this minus sign I'll merge with this outside minus sign, and minus minus become plus sign. This minus sign and this minus sign I'll merge together, it becomes a plus sign. Then here remaining parts I'll take the number which is there n minus 1, also can take outside integral sign, and here cos into cos we get cos plus sin raised to n minus 2 x into cos square x dx. This you got next step. Now while integrating the next part, our integrand or our reduction formula for sin is there this way. So whenever you get integrand containing other than sin functions, means like cos, say cosec, convert them into sin form for our easiness. Next step I'll write here in equal to minus sin raised to n minus 1 x cos x. This is as it is, no change, plus n minus 1 integral also as it is, sin raised to n minus 2 x as it is. Now this cos I can write by using alternative 1, sin square plus cos square equal to 1. Here you get 1 minus sin square for cos square. For this cos square you get 1 minus sin square. Now we can go ahead to find out next term, and I'll use next slide to find out this integral. Now we got the previous term, simplify it. In equal to minus sin raised to n minus 1 x into cos x plus n minus 1 into integral sin raised to n minus 2 x into 1 minus sine square x dx. 1 minus sine square x dx. You can split up that term, integrand term, with the sine raised to n minus 1. In equal to minus sine n raised to x raised to cos x plus, now here n minus 1, this is as it is. 1 you integral you get here sine raised to n minus 2 x dx. Then minus you get one more term n minus 1 into this, multiply with this one sine square, you get integral sine raised to n minus 2 and plus this 2 plus this 2. I'll write with a different color, then we will get idea what should be here added. Here adding 2 index of this sine power square, we get this one. Now this you can simplify. Here in equal to minus sine raised to n minus 1 x cos x plus, if you observe this integral, you can observe this integrand. This integrand looks like our first integral. Now we have in equal to integral sine raised to n x dx. This is in. Now here we have sine raised to n minus 2. Sine raised to n minus 2 means what will get sine raised to n minus 2 means n minus 2 equal to integral sine raised to n minus 2 x dx. This is in minus 2. Now in place of that one, I'll write here in minus 2, this middle term in minus 2. Then minus n minus 1. Here this 2 get cancels, becomes again integral sine raised to nx dx, and that is nothing but our in. That is nothing but our in. Now here you got both sides in terms, both the sides in term, that is also here. Now here is one in term and here also one in term. Collect both the in term to one side. Therefore here in coefficient is, this is in, you can take common outside. Here is 1, this coefficient of this in is 1, and this shifted this side, right side to left side, it becomes plus n minus 1 plus n minus 1 bracket complete is equal to the remaining right side term as it is, minus sine n raised to n minus 1 x into cos x plus we have n minus 1 into n minus 2. Now you simplify left side, then here 1 plus n minus 1 is minus 1 plus 1 get cancels, remaining only 1 n. And I'll go to the next step. N is left out as a coefficient of in equal to minus sine raised to n minus 1 x cos x plus n minus 1 n minus 2. And this expression or this expression is also by using the previous n minus 1 term, integral term, and in integral term, we reduce this integrable into algebraic formulas, and that I can write in directly standard form. In equal to divide both sides by n minus sine raised to n minus 1 x cos x, this divided by n plus n minus 1 upon n into in minus 2, and this is called as the reduction formula for integral sine raised to n formulas. And this is for infinite integral. Integrals are not given. And I'll go for next slide. Then how to convert this integral into a definite integral which has given limits. Now here, now this integral in is integral sine raised to nx dx. Now for this, if you take the integral in, limits of integrals are 0 to pi by 2. So to pi by 2 and sine raised to nx dx. Now such cases, now our previous reduction formulas can take as it is, in equal to, then you get here minus sine raised to n minus 1 x into cos x divided by n. For this you put limits 0 to pi by 2. Again we got plus n minus 1 upon n in minus 2 n minus 2. Then here no sine cosine terms, you can write as it is, and where cut is sine cosine terms, you can put the limits. Now here in equal to, if you put upper limit here, then sine pi by 2 is 1, but cos pi by 2 is 0. I'll write here the upper, if you replace upper limit sine, you can put here 0, and you can go for cos here in, that like. Now here by putting upper limit pi by 2, the whole term goes to 0. Similarly, go for lower limit, put now x equal to 0, sine 0 is 0. Then we get second limits n minus 1 upon n into in minus 2. Now here the first term is gone totally 0 for the finding the reduction formulas for the limits 0 to pi by 2. Now you got n minus 1 upon n into in minus 2. This is the reduction formula for the integral of sine raised to n x dx. This is formula. Now similarly, if you want to reduce, again calculate n minus 2, n minus 3. I'll go for next slide. After, again you can calculate value of in minus 2 by using reduction formulas. Then we get a such integral case. I'll write directly formula here. In for the sine function you get n minus 1 upon n into, again here n minus 1 gone on top. Now then n minus 2 comes down, and here n minus 3 goes to numerator, alternate one up, one down. Then here n minus 4, n minus 5, then here n minus 6, n minus 7, and so on. We get so many terms, and lastly into p, into p. I'll say what is the value of p. Depending on the power of or the value of n, then that p takes the role in the integral. What is the role? I'll show you. If p takes two values, either pi by 2, either it's pi by 2, or it's a 1, pi by 2 or 1. Then it takes pi by 2 if n is even number, and when it takes 1 if n is odd number. Means then in means suffix n is indication for integral. Suppose I here sine raised to 3x dx. If you want to find out its answer directly by using reduction formula, then I'll write here answer. Just I'll go here one of the now. Here, this is you can say its example. And equal to integral sine raised to x sine raised to cube x. Now this can be written by using reduction formula. Now this power is there here 3. Number 3 is an odd number. 3 is an odd number. Then take first 1 upon 3. In the numerator, reduce by 1. 3 minus 1, that is 2. Again 2 minus 1, here 1 into here p get now here odd is there, odd means here 1, here 1. Then the value of integral sine cube x dx is 2 by 3 for the limits 0 to pi by 2 limits 0 to pi by 2 limits. Now if you take that any other examples which has even powers, suppose in equal to integral 0 to pi by 2. Suppose I'll take a number, bigger number, cos raised to 10 x dx. Sorry, sine raised to x dx. We'll take sine only. And sine and cos both having the same one. Consider this way. Here. Now I'll take here sine raised to 10x dx. Here the power is 10. Now here n equal to 10. This is a even number. Even number. Then how we will reduce this integral into simple answers? Then in equal to, we get in value for this one. Here index is 10. That we take first start with denominator. Here 10. Then numerator reduced by 1, 9. Then again here 8. Again here 8 minus 1, 7. Again 7 minus 1, 6. 6 minus 1, 5. Then here 4. And here 3, and here 2, and here 1. And these are the products, okay, numerator and this one. This into this. Now, lastly, the value of p. Here the number is even number. That's why p takes value here pi by 2. P is pi by 2. Here due to the even power of that side. So here pi by 2 is for the even power. So by that you can calculate any higher powers of trigonometry functions standard values by using without any explanation, without any steps. Directly you can use reduction formulas method and to get the answers. This is the important formula to reduce the given integral of sine functions into the soluble form or in solution form. Now we can go for the next slide. Now I'll give here in the next slide a simple tricks for sine and cos. Both are same for integrals. Now right here the integral reduction formula for 0 to pi by 2, 0 to pi by 2 sine raised to nx dx formula is same as some formula for cos also pi by 2. If you can check by solving yourself, cos raised to n x dx. Both the functions sine and cos for limits 0 to pi by 2 we have same reduction formula. Then that will get here. First we take that index which is given into the examples. That index you can say it is n index. This is sine and cos is given here index n. That must be written here down. N, go on reducing 1 1, n minus 1. Again here n minus 2, here n minus 3, and down here n minus 4, then here n minus 5, n minus 6, n minus 7, and so on up to last, depending on even or odd, and here into p, into p. Now the role of p again I told in the previous sine function is in the form of either pi by 2 or 1. When it is pi by 2, If n is even number and if n is odd number, that value of p takes either pi by 2 or 1. This is the reduction formula for the sine and cosine functions. And whenever the limits are given to you 0 to pi by 2, this is standard formula to reduce them into a simple numerical values. Now, when limits are other than 0 to pi by 2, how to split up these values? Just we'll check some notes format. Can say the simple note format, and it's a very important concept for the functions. Now we'll check if limits are other than 0 to pi by 2, how to reduce these fundamental integrals into a standard relation formulas. Now suppose if I take here 0 to 5, 0 to pi limits. Now be carefully here, check it. Now our limits are becomes 0 to 5. In place of 0 to pi by 2, I took here 5. Now sine raised to n x dx is equal to, this you can write 2 times. 2 times integral 0 to pi by 2 sine raised to nx dx for all integer n, for all integer n. Now similarly for cos, can check carefully, observe it. Then what will becomes for the cos if the integral is 0 to, now for cosine function, if integral is 0 to 5, cos raised to n dx is equal to 2 times integral 0 to pi by 2 cos raised to nx dx. This is possible only for n is even integer, even number. If n is even number, that term only is possible for 2 times. Otherwise, it becomes 0. It's a 0 for n is odd number. N is odd. This is very important. For sine, both the numbers, for the odd or even number, the sine becomes 2 times integral 0 to pi by 2 sine raised to nx dx. But cosine, for odd number, it becomes a 0. And this same concept we are going to use for the combined functions, mixed functions, sine cos mixed functions. Now this is we learn for the 5. Now what about next one? I'll type here with the statement. Now limits, in place of pi, I'll take here limits 0 to 2 pi, 0 to 2 pi. Now for sine raised to n x dx, sine raised to n x dx, this can be written as 4 times integral 0 to pi by 2, 4 times integral 0 to pi by 2 sine raised to nx dx. Now this is possible only for n is even number, n is even integers. Otherwise it goes to 0 for n is odd integer, n is odd integers. Similarly for cosine also. Then I'll write here, even for cosine also the same rule is there. Integral 0 to 2 pi cos raised to n dx is equal to 4 times integral 0 to pi by 2 cos raised to nx dx for n is even number and is equal to 0 for n is odd number. This is very important slide here. Whenever we got the another conditions, I'll take here different sketch. Here limits are 0 to pi by 2, 0 to pi converted into 0 to pi by 2 by taking 2. For sine, for all integers, sine becomes 2 times. Cos becomes only for even time, that time it will become 2 times, otherwise it will not becomes 2 times. For 0 to 2 pi, all even numbers, it becomes 4 times integral 0 to pi by 2, 4 times. For cos also 4 times for even number only, otherwise it is a 0. Otherwise it is a 0. Now I'll go for next slide. If they ask to mixed function means integrand containing sine as well as cosine functions. And there is also one shortcut reduction formulas, and that reduction formula helps us to calculate any higher integrals or multiple integrals. That time we are going to use this concept into multiple integral topic to calculate these integrands directly by using these reduction formulas. Now I'll take one simple formulas and I'll get directly give you what is that formula. Now integrand containing sine and cos, both sine raised to mx, cos raised to nx dx. Here you can see then how we are going to denote for this integral. Integral I m n, I m n equal to integral sine raised to mx cos raised to nx dx. Now for this courses will not ask you how to get these reduction formulas. Even if they ask also, you can split up into the required integral forms. Now even if they ask you how to split up this integral, then you can convert them into cos function. You can convert into two functions. Then this cos integral can convert into, just I'll show you one simple steps. Then I'll go to that. Now this cos to n minus 1 can split up into cos raised to n minus 1 x into cos x into cos x, and take this sine function, sine raised to m, this function and this function as a one function, and this is one function. This is a one function. Means by part how to use integral cos raised to n minus 1 x into, I'll make bracket here, sine raised to m x into cos x, then this dx. And you can use here, this is one is the first, this is u and this is v. Why these two collected together? We have one standard integral formula. Here integral is f of x raised to n into f dash of x dx. F of x raised to n into f dash of x dx is equal to that f of x power is increasing by 1, f of x is to n minus 1 upon n minus 1. This is the standard integral formula. For this is easily integrable. So sine and cos higher powers are collected together with one single sine and cosine term. This way, for using this concept, you can get a important formula for this double function integral sine raised to m cos raised to n x dx. Now I'll go for directly for 0 to pi by 2, 0 to pi by 2 expression. Now for this, how will get a fundamental formula to get the directly answers for the pi by 2. Now I'll directly explain you how to get this fundamental structure or relations or equations. Now this equation number 1, you can say, I'll go for it. Let's write easiness for the understanding. Now we are going to solve now of I m n, this integral containing limits 0 to pi by 2, 0 to pi by 2 sine raised to m cos raised to n x dx. This is the integration which we are going to reduce into a standard formula. Now by solving LIT rule, I split it into previous integral, then we can conclude that this in can be written as standard formula. Now how to split like this previous examples. Now make how to split up this. I'll use different here things. So first add up both the powers. First add both the powers m and n. and that must be added here, m plus n. Add both the powers and go on subtracting 2 at a time. M plus n, 1 for m, 1 for n means that is minus 2. Minus 2. Next bracket, m plus n minus 4. M plus n minus 4 and so on. Go up to last 2 or 1. 2 or 1. Then how to write down the numerator? I'll again use a different. Now here we have m minus 1, m minus 3. Directly take one jump. Why? One term is going down, one term is going up. Okay. Difference between these two. M minus 5 now, and so on, and so on. Then we can use here for the n, here n minus 1, n minus 3, and so on, and into, just I'll take this one down, here into, we get again, write here the same symbol, into p, into, then what are the value of p, you can get it. Now, very important here concept, p has two ranges, p has two ranges. If it is pi by 2, if both m and n must be even number, both m and n must be even number, then we can write it p is pi by 2. And for any other values of m and n, for any other value of m and n, other value of m and n, you get here 1. You can write here 1. This is for integral 0 to pi by 2. Now, I'll go to next slide. The very important concept is that for different limits, how these double integrable functions can be evaluated or reducible to Russian formulas. Now, this is very important. First one, I'll say I m n integral 0 to pi by 2, which you learned just now formula, integral 0 to pi by 2 sin raised to mx cos raised to nx dx. That formula. Now, for other limits, what will happen? For other limits, now I mn for the another limits, that is 0 to pi. Carefully you have to observe it. 0 to pi sin raised to m cos raised to n can be split into 2 times integral 0 to pi by 2 sin raised to mx cos raised to nx dx, only for n is even number. N is even number. M may be any value. M may be any value. And this is second value is equal to 0 if n is odd number. Here n is a coefficient or power of cos. Same rules here also. Or if cos powers are even number, you get double terms. If cos powers are not even number, it becomes a 0. It becomes a 0. This is very important concept here. Integral while 0 to pi converted into 0 to 2 pi. That time you check the power of the cosine term. Cos term is even number. That time only it exists. Otherwise it becomes a 0. Now we'll go for multiple limits. I am equal to limits from 0 to 2 pi, 0 to 2 pi sin raised to mx cos raised to nx dx is equal to, now it becomes 4 times integral 0 to pi by 2 sin raised to mx cos raised to nx dx. Now here, if both m and n are even number, both m and n are even number, only possible 4 times. Otherwise, it is 0. Otherwise, it is 0. Otherwise, it is 0. This is a very important concept here. We have to keep in mind. Whenever we have limits of double 0 to 2 pi, 0 to 2 pi, that time both m and n are even number. That time only the integral becomes 4 times. Otherwise, it is a 0. And for limits 0 to pi, you check only cosine powers. Cosine powers are even number. That time it becomes a 2 times. Otherwise, it is a 0. Otherwise, it is a 0. And for integral 0 to pi by 2, 0 to pi by 2, we get conditions of that one. 0 to pi by 2. If both are even, we get pi by 2 multiple. And if both are, if the mix of format, multiple into 1. Here, p is pi by 2. Multiply with pi by 2 integrals. Okay. Now, this is a very important concept for the reduction formula. Now, we'll check one of the examples. Now, we learn up to here if integral containing sine and cos. I'll use next slide. If integral containing other than sine and cos, suppose we got integral I n equal to, you can say tan raised to n x dx. How to split such integrals? Now, while splitting time for sine cos, we split it like that, n minus 1 and n 1. Now, here, if you split like this here, tan raised to n minus 1 into 1 tan x, and either this is not integrable and this is not easily integrable. Therefore, we have integration of tan square x. We have integration of tan square x dx. And you can split this integrand, which we have integrable function. That's why such integrals in equal to, you can split this integral tan raised to n minus 2, one term, and second term is tan square x dx. And tan square you can convert into 1 minus sec square by using identity number 2. Like that, for sec and cosec also, sec, cot, cosec, you can split into the double powers. All can split into double powers. Even for cosine also, for sec also, suppose integral sec raised to nx dx. If you want to split this integral, you split it into sec raised to n minus 2x into sec square x dx. Here easily you can integrate the second part, sec square x. Here tan square convert into sec square and integrate into that line. That's why the other terms while splitting you can take two terms as a integral terms. Now we'll learn one of the simple concept. Just erase this all part. Now we'll see one of the simple example and which has all these applications, wide applications of this reduction formulas. Now I'll take one simple example, one simple concept which has these all applications. Now suppose I have integral 4 to 6, limits of the integral 4 to 6 sine pi x raised to 4 cos 2 pi x raised to 2 dx. Integral 4 to 6 sine pi x cos 2 pi x. Here you can observe it, both the limits are not in it. Here pi x is there and here 2 pi x is there, and even the trigonometric angles also not same. Such cases we need to substitute. Okay. Such cases we need to replace this pi x equal to t. change of parameter form. X equal to t, then by differentiation you get pi into dx equal to dt, then change of the limits you get. Here integral becomes integral I equal to integral 4 to 6 sine raised to 4 pi x cos raised to 2 pi x dx can be reduced into the integral formulas. I'll write here integrals is equal to, now here pi dx is there, then I'll write dx equal to dt upon 5, dt upon 5. Here this dx, I'll write here integral. Now check limits, simultaneously limits. What limits will going to change for the substitution? You put pi x equal to t, the lower limit is here x equal to 4 here. Put x equal to 4 here, t becomes 4 pi. T becomes 4 pi. And we put x equal to 6, t becomes 6 pi. T becomes 6 pi. The limits become 4 pi to 6 pi. Now our constant limits are converted into pi format now. Pi format. Then by substitution here, sine raised to 4 as it is. Pi t, pi x can be written as t. Pi x is written as t. And here cos raised to 2 t into dt upon 5. The dx value becomes dt upon 5. And this can be written as 1 upon 5 can take outside integral sign. And limits becomes 4 pi to 6 pi. 6 pi sine, I will take this 4 pi to 6 pi sine raised to 4t cos raised to cos square 2t and dt. Now again for this step you can replace by supplementary limit rule. T minus 4 pi equal to another parameter. It's lower limit. Some parameter minus lower limit to get another form. Then therefore when t tends to, the limits I'll write here how to convert the new limits. When t tends to 4 pi, the time u tends to 0. 4 pi minus 4 pi tends to 0. Means now our new limits what I'm going to change here. If t tends to 6 pi, then our u tends to, we put here 6 pi, it becomes 2 pi. We say 2 pi. Then our integrand I becomes 1 upon pi as it is. Limits here 4 pi goes to 0, and this becomes 0 to 2 pi. Limits become 0 to 2 pi. Then sine here, sine is to 4. Here in place of t becomes 4 pi plus u. 4 pi plus u. And same also cos raised to 2 times 4 pi plus u. And differentiation you get du. You get du. Now I'll use one more slide to split up this integral. Therefore integral I becomes 1 upon pi integral 0 to 2 pi 0 to 2 pi sine raised to 4u cos raised to 2 and 2u du. Now sine 2 pi plus theta is again sine theta. Sine 4 pi plus theta is again sine theta. That's why sine of 4u 4 pi plus u is same as sine u, and cos of 4 pi plus u again cos u itself only. Both are in the first quadrant. First quadrant all are positive. That's why no change in the limits. Now it becomes 1 upon pi limits 0 to 2 pi sine raised to 4u cos raised to 2 to 2u. Now we have a cos square formula, sin square formula, cos square 2 theta formula, cos square 2 theta formula is nothing but cos square minus sin square. Cos square minus sin square is equal to 1 upon 5 integral 0 to 2 pi 0 to 2 pi sin raised to 4u into cos square u minus sin square u into du. Here we applied cos 2 theta formula. Cos 2 theta formula is whole raised to bracket. Cos 2 theta formula is cos square minus sin square. Cos square theta minus sin square theta. This is formula for the cos theta. And here bracket square is there. And if you split up this integrand or this integrand with the limits and the brackets 0 to 2 pi, it becomes sin raised to 4u into we get cos raised to 4u minus 2 times sin square u cos square u plus sin raised to 4u. This is bracket expansion by using a plus b bracket square formula. Now you can split up these integrals into different integrands. Now 1 upon pi I'll keep outside. The remaining terms you can split it into like this here. Integral 0 to 2 pi 0 to 2 pi sin raised to 4u cos raised to 4u du plus I will take here minus n, the middle term is minus n minus minus sin minus integral again 0 to 2 pi 2 times sin raised to here 4 is there and here 2 get sin raised to 6u sin raised to 6u into cos square u into cos square u du plus integral 0 to 2 pi 0 to 2 pi. Here sin raised to 4 and here also sin raised to 4. We get sin raised to 8u du and this becomes the our important split up. Therefore, I integral equal to 1 upon 5 already got outside. Now each integral. Now this integral I'll write it one more times. Integral 0 to 2 pi sin raised to 4 cos raised to 4 u du splitted into form plus minus sign 2 times integral 0 to 2 pi sin raised to 6u cos raised to 2u du and plus lastly integral 0 to 2 pi sin raised to 8u du can be splitted into integral formula by using reduction formula. Now here is very important step here. I equal to I write 1 upon 5 as it is outside. Now here again limits are 0 to pi by 2. 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 While converting them into 0 to pi by 2, 2 pi converted into 0 to pi by 2. Here limits are 0 to 2 pi, 0 to 2 pi, 0 to 2 pi, and we are going to convert into 0 to pi by 2, 0 to pi by 2 by using reduction formulas. Right here, bracket. Here both the powers are even number, therefore it becomes 4 times integral 0 to pi by 2 sin raised to 4u cos raised to 4u du. Both the indices of sin and cos are even number, and directly can write in 4 times integral 0 to pi by 2 minus sin 2 as it is here 2 is already. Here again both sin powers and cos powers are even number. It becomes 4 times integral 0 to pi by 2 sine raised to 6 cos raised to 2 u du. Plus, now you can observe here 0 to 2 pi. Now it's a sine function. Say sine function directly you can convert it into sine function. The even power either can convert into 4 times integral 0 to pi by 2 pi by 2 sine raised to 8 u du. Now here this is very important step is that for converting them into 0 to pi by 2, 0 to pi by 2. Now here we usually here that reduction formula is converting them into reduction formula. Here you can take 4 times, you can take 4 times, here you can put 4 times due to the even powers of sine and cos. Therefore, you can use reduction formulas. I write here directly answers here 1 upon 5. For this, here 4 into, I'll explain one integral directly. Add both the answers, both the powers. 4 plus 4, 8. 8 into minus 2 means 8 into 6. 6 minus 2, 4. 4 minus 2, 2. Then last 1. Now, in numerator we get 4. 4 minus, right here 4 minus 1, 3. 3 minus 2, 1. Again similarly here 4 minus 1, 3 into 1. Now into here both are even number, therefore it must be 5 by 2. It must be 5 by 2 minus 8 times. Again here same when both are even numbers, and I'll use here differently to write down middle terms. Now here 6 plus 2, again 8 into 6 into 4 into 2 into 1. Now while writing numerator 6 minus 1, 5. First number is 5. After that 2 subtraction 3, 1. Here 2 is there. 2 minus 1 means 1 into 1. Both are even numbers, then 5 by 2. Both are even number, then 5 by 2. I'll use one more different colors to show the last integral. Plus 4 into. Now here it is sine function. Sine function means then go on writing. First is denominator. Afterwards it's a 8 minus 1, 7. And 7 minus 1, 6. 6 minus 1, 5. 5 minus 1, 4. 4 minus 1, 3. 3 minus 1, 2. 2 minus 1. And this number index is here again even number. Multiply with 5 by 2. Multiply with 5 by 2. Now whole bracket completed with this 5 by 2 multiplication. Now finally by simplification you get this answer. Here everywhere 5 by 2 is there. Also 5 by 2, also 5 by 2, also 5 by 2. And this 5 by 2 can take also 5 take outside and just keep it. So we get required answer here in numerical form. That's why reduction formula is very applicable to find out a solution of higher integrations which are infinitely integrable functions as well as infinitely differentiable functions. For this we will stop today here. Then we will see next video then how to find out solutions of some standard examples.